I'm in the middle now of removing the old tires from the wheels and prepping them for the new wheels. I've just finished getting off the tire from this first one. You can't see it too well because it's a lot cleaner than it was immediately after I took the tire off. And we're going to move on to the bottom wheel now. This is the old tire, and interesting to see the path that the blade made on it. Something was off with the tracking, and I can see even that the tire was not on quite straight. That's the condition of the old tire, so yeah, we're definitely getting this off. And then, once this is all off, I've got to take off this old dried adhesive. There we go. The next step will take a lot more time, but I figured it out how to do it a lot quicker with the top one. And here's how I'm getting the old adhesive off. It's going to be a combination of heat and acetone or mineral spirits and a little bit of a wire brush wheel. And there's the second wheel. Acetone was definitely the way to go. I guess the original glue was what do you call it? An acrylic, something that dissolves in acetone. In any case, this is ready to get the new tire and the contact cement. It's definitely abraded enough, especially after all of this. The acetone loosens it up enough that the wire wheel made a lot shorter work of it than mineral spirits would. Anyway, let's get this back on the saw. Got the old tires off, the old adhesive off, and at great effort, the new tires on. I didn't show putting those tires on because it took a long time and not fun to watch or to perform. But they are on, and I'm going to put some contact cement on them in a little bit. Before I do that, I'm going to try out the blade just to see how it's tracking because I'm curious. The way I put the tires on is by putting a big woodworking clamp across both sides and then working it over with this tool that the guy who sells his Bandsaw tires includes in the tires. And this was really invaluable. Got them clamped and then just kind of held it down and worked the tire around one half and then the other half. Well, it's back together, and it did this. A really horrible looking cut on this piece of wood, but I suppose that's more or less the condition that this saw was in, minus the whole upper blade guide thing going on. It's definitely time for me to put contact cement on the tires. This was on the slowest speed on the step pulleys. I brought it up to the second highest speed, and it threw off the tire. Threw off the blade from there too. So we're going to put the contact cement on this, and then at that point I would say we're done with this part of the restoration. What would come next is the jackshaft. Now that I determined that the bandsaw will cut something as a wood saw, I'm going to take it all apart and get to making the jackshaft so that I can slow this down to a feet per minute appropriate for metal cutting. Here is our arrangement for the jackshaft. The motor's pulley will be pointing in this direction, driving this large pulley, and the shaft will be turning on the smaller pulley, which will be driving a larger pulley at the saw itself. Welding didn't go so well, so that's why you didn't see any of that. I've resolved to get more practice TIG welding and not just bang my head against the wall trying to get this to weld. And instead, we're going to just cross drill it and drive some screws into it. Now that I've got the shaft mounted, I can kind of see more exactly where things will go in their final position. And I can see that it's going to work. I won't be able to use this belt, and I'll have to take off some of the frame here, but I won't have to take off any of these parts original to the saw. So that makes me happy. I'm ready to go over to the mill and cut the key seats on the shaft. Got the shaft here in the vise, and we're going to mill for a 3/16 keyway. So the shaft is done and the pulleys are on and they fit. My next step is to make a base for the motor. And that means taking the saw off of the base one more time. Got the big burrs cleared off of it, got the little burrs filed off of it, and now it's time to cut up some angle iron to mount it to the frame. So this is how the base that's going to hold the motor is going to look if we're looking at it from underneath the thing. So I have to not only had to cut these out to length, but also if I want all this to be flat, and I do, I have to cut out a square over there and a little bit on this part too. I have to do the same thing on this piece as well. And there we go. That's the best fit up I've gotten so far. I've kind of wasted two pieces, although I'm sure I'll use them for something else. And now I'm ready to get these angles cleaned up and get them welded to the plate. Got the metal all cleaned up, de-rusted and ground, cleaned off with acetone as well as my rods, and I'm all ready to practice welding a bunch of beads on a plate. Two rods, 200 psi of argon, and about 3 hours later, and I've gone from this, just running the torch across the bead with no filler, to this, on down, introducing the filler. And then I practiced some lap joints and figuring that out. I'm going to do this lay wire, which I gradually figured out and trying to avoid undercut while still getting the fusion. And now I'm ready to actually do the real thing, since I only get one chance. There we go. So the belt contacts the frame of the saw base when it's on the saw's pulley, and so I've got to cut out a little notch from the frame. And I was going to do this with an angle grinder, but I didn't want to cover up the lathe, and I didn't want to drag this outside to cut it outside. So we're going to hacksaw it, and it's going to be one of those situations where it takes a lot of effort to be lazy. So notches are cut, and now the belt will not hit those notches. And once I get a longer belt, I'll be able to put the pillow block down onto the base where it's supposed to go. The jackshaft was successful in slowing down the feet per minute of the saw, and now it's ready to be put back together and tested. By this tachometer, the saw is running at 375 RPM. When using the footage wheel on this tachometer, you divide the number on the dial by half. And that is high for cutting steel. Ideally, we'd want 100 to 120 feet per minute, although I can still rearrange one of the cone pulleys to adjust for that. Let's do a practical test now on this piece of angle. This blade has a compound pitch of 10 and 14 teeth per inch, which means I can cut as thin a workpiece as 9/64ths by the rule of having at least 2 teeth engaged in the work at all times. We start at a depth of cut of 1/8 of an inch and move on to 1 inch. I wasn't pushing all that hard. I was going quite I was going quite soft, especially on the 1/8" part. It slowed down definitely when I got to the 1", and the blade is not warm at all. I'm satisfied with what the saw was able to cut, especially since the reason why I wanted to get it working right away is that I'll be using it in making an overarm support for the Nichols mill. With that, I'll be a little bit closer to using the Nichols for what it was intended for, horizontal milling. What's left in the restoration is wiring in a permanent switch, making an insert for the table, and guards for the pulleys. But while I'm doing that, I still have a metal cutting bandsaw. Well, I'll make that too. And if I ever want to cut wood, I'll figure that one out when I need to. Isn't it funny how these say adjustable on them? Unless adjustable is the brand. What kind of C-clamp is not adjustable?